In this video, we are going to go over a few examples of problems related to translation. Translation is one of the three types of rigid transformation, and is usually considered to be the easiest of the three, since it doesn't involve turning or flipping the shape at all, it just involves changing its location. So as long as you have a good sense of how a two-dimensional graph works, then you should have no problem doing basic translations. For instance, this problem says translate triangle ABC 3 units to the left and 4 units down to create triangle A prime, B prime, and C prime. So the first thing that we can do is we can dissect what this means. 3 units to the left means that the x value is going down by 3 because we're going to the left. So if you imagine the x-axis as a number line, we are going down that number line. And then 4 units down, that is the y value going down by 4. So what's that look like? Well, if we start at point A, then we can simply just count backwards 3, 1, 2, 3, and then we can count down 4. 1, 2, 3, 4, and we end up at A prime right there. Now, take note that A compared to A prime is a diagonal distance, but we are using the cardinal directions of left, right, up, and down in order to make an easy path of travel. Once we've finished A, we can do the same thing with B. 1, 2, 3, and 1, 2, 3, 4. There's B prime. And finally C. 1, 2, 3, and 1, 2, 3, 4. And we get C prime like that. And of course, the easy way to tell if you are doing things the correct way is to take a look at the original shape, compare it to the new shape, and make sure that they look exactly the same. The direction's going to be the same, everything's going to be the same, except it's going to be a copy in a new location. You could encounter a problem in which you are not being given the translation. You are instead asked to describe the translation that has already been started. In this case, the problem says translate triangle ABC so that A prime is in its new location. Describe the translation. So here's A prime in its new location. Here's A in its original location. Now the key here is that A and A prime are what we call corresponding points, which means that if we want to describe the translation of the shape, all we have to do is describe the translation of A to A prime, since it's going to be the same for the rest of the shape. So we calculate how we get from A to A prime. We're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 to the left, and then 1, 2 down, and 2 down. So we've taken care of describing the translation, which we had to do anyway according to the directions, and now we just have to repeat these steps for B and for C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 2 down. There's B prime. And same thing for C prime. If I don't want to calculate all that, I can just notice that B and C are just 4 units away from each other. C is 1, 2, 3, 4 units to the right of B. And since this is a rigid transformation, the shape's going to be the same. That means that I could just count 1, 2, 3, 4 to the right of B prime, and I'll find C prime. That's just a little shortcut. There you go. And the shape looks identical to the original, just in a new location. Finally, we could encounter a problem in which there is no graph. All we are given are coordinates, and we are being asked to perform a translation. Now, I guess you could pull out a piece of graph paper and draw this coordinate and complete the translation and then figure out what the coordinate is, but there are shortcuts. So, we're going to talk in this one about the mathematical way to talk about translations. As we talked about earlier, we can talk about translations as changes in the x value and the y value. So in this case, 5 units to the left, well, that is the x value going down by 5. 6 units down is the y value going down by 6. So if we're starting with -3, 5, don't forget that a coordinate is nothing more than an x value and a y value for that point. So if we want to administer a change in the x values and the y value, all we have to do is add or subtract. In this case, subtract from each value. Since the x value is going down by 5, we're subtracting 5 from -3, and we end up with -8. Since we're starting at +5 for the y value and subtracting 6, we end up at -1. And there's our new coordinate for A prime. Much easier than taking out the graph paper, right?